Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the moderator. I will to present my paper. The title is Experimental Investigation of Thermal Conductivity of Aluminum Dioxide, Titanium Dioxide, Silica Dioxide, nanofluid in EG water mixer for automotive radiator cooling system. And my name is Anwar Ramadan, and the partner is Eri Deniardi, Hasan Basri, Daniel Manda, Wan Hamza Azmi. We from Department of Mechanical Engineering, Faculty of Engineering, Universitas Muhammadiyah, Jakarta. Let's go to the next slide. The second slide, I will to present about presentation outline. The first is introduction, the second methods, research and discussion, the last is conclusion. Introduction, the formulation of a new type of heat transfer fluid known as nanofluids, application on automotive, heat exchanger, thermal power plant, chemical processes, electronic equipment cooling, petroleum refineries, and food industry. I will refer Umar and Saidor, right? And the second is the inclusion of solid particulates in interviewing characteristic of nanofluid fundamental thermophysical properties. Many researchers have studied thermal conductivity, viscosity, density, and stability. The purpose of developing hybrid or nanofluid composite is to improve the properties of single nanoparticle in order to improve thermal or rheological capacities. And my purpose of study, the first is to improve heat transfer performance. Hybrid or composite nanofluid are being developed. And the second is to study what's conducted by imposing the influence of the ratio of the three nanoparticles to get the thermal conductivity higher. Okay. This is my methods in my project experiment. The material, of course, we use properties for aluminum oxide, titanium dioxide, and silica dioxide. In this table, I will mention very important to make it nanofluid is average particle diameter. Make sure your V nanoparticle in this range, right? Aluminum 30 and titanium 50 and silica dioxide 22 nanometer. And the table of second, I will to try use of ethylene glycol. Okay, the next slide about to preparation of trihybrid nanofluids. The life from the figure base fluid EG water. We use EG water, and after that I will mix the nanoparticle for each nanoparticle aluminum, titanium, and silica to make it nanoparticle suspension. After that we use instrument tools, magnetic steel, and ultrasonic vibration. The function of the ultrasonic vibration is to homogenize nanofluid. We will make it. Okay. And then how to measurement of thermal conductivity my hybrid nanofluids. And this figure KD2 Pro thermal for thermal conductivity measurement. Thermal conductivity measurement, our rank for temperature 30 and until 270 degrees Celsius. And after that, we validation of thermal conductivity values using standard liquid is glycerin by Decagon devices. And the measurement time for each set data was about 50 minutes for each set data at different temperature. Okay, result and discussion. This is about validation of thermal conductivity. We compare EG water with acerine, right? We'll look at in the figure, the line is thermoconductivity to be validated with ASRAE for EG water 64 80. And this is a result measurement using KD2 Pro, right? The measurement of thermal conductivity using KD2 Pro validation results with 1.5% deviation. Okay, and this figure result for my experiment use KD2 Pro. Effective thermal conductivity increased with 0.3% volume concentration. Exactly for 0.05% is very, very low. So we can see significantly any relationship volume concentration and for its set of temperature. Okay, comparison with literature. Effective thermal conductivity of trihabit nanofluid increased by 1.02 until 1.06 times. For concentration, 0.1%. If we compare Nabil and Murset using aluminum oxide and titanium dioxide, silica oxide, or we call hybrid nanofluid particle, with 0.5%, very high if we compare from my nanofluids. Conclusion: the highest thermal conductivity was obtained for trihybrid nanofluid at 0.3%, with a maximum increase of up to 9% over the best fluid EG water mixture. Aluminum, titanium, silicate nanofluid at 0.05% concentration have the lowest effective thermal conductivity of 4.8% at temperature 70 degrees Celsius. Okay, this is my end presentation. Thank you very much. Terima kasih. Matur suwun sangat.